So the audio is recording, the video is recording, and sync. Hello, welcome back to my channel, and today is gonna be a little bit different, like kind of a video. So today's video is actually a Python tutorial. I'll just get you started on how, like, the introduction, the very brief introduction to Python. And I'll be taking you through like some codes here and there to understand, to make you understand a bit better about Python, right? And I won't be going through the installation part, but please do install Python and Anaconda. I'll leave a link in the description for the download link and as well as the tutorial link for you to install it properly, right? So without further ado, let's just jump into it. So right now I'm using Google Colab, which is a fantastic coding environment. I can actually change the runtime to GPU to run like a lot of like machine learning and stuff like that. So it's a lot faster, and I'm using Colab so that I can actually share this notebook to you guys in the description down below, so that you can actually follow through the tutorial and do it by yourself, like during the tutorial or after the tutorial. Yeah, right. So so this tutorial is consisting of very like basic fundamental stuff like the very basics, hello world, data types, yada yada yada. Then I'll be going through the list, the dictionary, conditions, the if, elif, and else, and the for loop and while loop. Then I'll be diving in a bit deeper about the strings and the object-oriented programming. Right. So the first thing you want to try with your Python is hello world. So for you to how to say for you to execute the line in the collab, you just control enter or shift enter. I prefer shift enter. So just you know or you can alternatively you can just click this cell and boom. Okay, is it running? Okay, it's gonna take a while because it's just like getting set up and stuff. Yeah. Okay. uh Okay, nice. Okay, so well, once you see that there's this one, the cell has been like indicated one, that means it's already run, and you can print hello world over here. You see that the output is hello world over here, right? So we're going through the data types. So the first data type we see is a string. So a string is basically something like a word or a display, something you display on the screen. So like maybe that. Okay, a equals to oka, and I say type a. So so this data type is okay, never mind, I made a typo. Okay, so this data type is a string. So the next up is an integer. Integer is just any whole number value that you have. So let's say b equals to 5, integer type b equals to int. Int stands for integer, right? So c, okay, let's say c is 2.0, type c. Okay, so you see that even though 5 and 2 are whole numbers, but if I choose to represent it in a decimal place like 2.0, it's actually registered as a float. So yeah, a float is just something like a fraction or a decimal. Yeah. So and the next up we have a boolean. Boolean just means boolean just means equal, just is it true or false. Okay, hold on, type d is true. Okay, nice, boolean. Okay, so those are the four main data types that like you have as of now. As we go for like fourth, you actually learn more like list or dictionary, right? So yeah, and the standard operations we have. Okay, let's initialize some things, right? So I want to add a code. Okay, let's say a equals to 15, b equals to 2, right? Then I run this code. And addition, a plus b. Oh my god, not equals b. Okay, no, sorry. I need to run this code again. A plus b. Okay, a plus b, 17. Okay, you can do subtraction. where a minus b. Okay, multiplication, a times b, and division, okay, a divided by b. Nice. Okay, then you can actually do exponential as well. So it's a times b. That's an exponent. So meaning it's just so we see over here is 15 to the power of 2. So 225. Floor division. Floor division is something like how many times you can divide over. That's an integer. Okay, I'm not sure how it works. No, I'm sure how it works, but I don't know how to explain it. Okay, so it's a divided by b. So floor division, you can think of it like the maximum number of divisions that you can have. Okay, so let's say for example you have a divided by b is 7.5, right? Yeah, so you can divide 15 7 times, uh, like using 2, like uh, I think that's how you explain it. Okay, this is getting horrible. Okay, yeah, people are getting people are gonna click it out already. All right, then modulo is basically the remainder. Oh, okay, never mind. I can explain floor division in terms of okay, so when you do long division, right, is the like, is it what you call a quotient, or like, okay, it's not a quotient. Okay, when you do long division, it's something like it like floor division is something at the top, and then the modulo is something at the bottom. Okay, okay, I'll insert some like insane graphic over here to explain it. But moving on. Okay, then we want to write functions. So functions, you just define it, and okay, I says tell myself here that write a function to calculate the area of a circle, right? So definition area, okay, calculate area of circle. Okay, then okay, you have to close. Okay, you have to have a close. Okay, you have to have the definition, def over here to indicate that it's a function, and then this is the function name, and this is the parameters that you want to be having. So it's I want to have radius, because that's how you calculate the area of a circle. And okay, before we continue, this is just something that you have to do, because there's no like inbuilt pi value in Python, so I have to import. No, okay, not import math. So from, okay, yeah, just import math. Okay, nice. Then oh, okay, return. Okay, so a function, when you want to like have a function, like you need to have an answer, right? Yeah, so return, so that's when you like return is, so return radius by r squared, so radius, and math dot pi. Okay, see if I did it correctly. Okay, run this. Okay, nice. So I want to check it. So calculate area of circle. Okay, how? Okay, a unit circle. Okay, 3.1415. Okay, nice. Maybe how about okay, hold on. Calculate area of circle. Radius 4. Okay, voila. So that's how you actually calculate the area of a circle. So then you have a, okay, then the next function we want to go through is write a function to introduce yourself. So definition, introduction, name and age. Sure, that's how we do it. Okay, so just return my name is plus name. Okay, you know what, just, okay, we'll be going through the formatting of the strings in a while. So And then let's just have it as in name, and my name is okay. So strings, right? You can actually uh, do the same operation as the like addition and subtract, like addition and multiplication. So what you do is just yeah, you can basically add strings together. Yeah, okay. Yeah, you know what I you know what I mean. Okay, so okay. Introduction. Then you have to be in a parentheses. In the not parentheses. It's a quotes because it's a string. So introduction. Oka. Okay. My name is Oka. Oh, okay. This is okay. You have to remember space here, right? If not, it's okay. Never mind. I need to define it. All right. Nice. My name is Oka. Nice. So you actually have try yourself kind of exercises that you can do if you're interested. I'll leave a link to this Colab like notebook down below in the description. Right. So let's move on to list. Okay, 14 hidden cells. Okay, a list is just like a list of things that you can have. So I can have a list, ls. So the list is in square brackets. So 7, 8. Okay, then ls1, another list. Okay, I can have a list of names. Oka. Okay, what's a good name? I don't know. Alan, LeBron, uh, Kyrie, okay, etc. And then you can actually have lists consisting of different data types. So I can have Oka, I can have 2, I can have 3.9, I can have another Oka. Nice. Yep. So this is essentially a list. So you just define a list with a square bracket, right? So you can actually have a list inside a list. So what do we mean by this? So this means that list, or 1, 2, 3, and then 1, 2, 5, 1, 2, 6. All right, whatever. Okay. Okay, nice. So when you want to okay, you know, list 3. So when you want to like slice the list, right? Okay, okay. So we'll be going through what slicing the list is. So when you slice the list, it's basically calling like uh, specific parts of a list. So let's say you have I don't know, um, let's say you have a rope, and then you want to cut like this part of the rope, like so it's similar to that. So it's just like, okay, let's say one, you want to have like, you want to return one item of this list, right? Yeah, so one element of this list. So I'll say print list. Okay, so the list indexing is actually you when okay. So the list indexing, I have to introduce it to you because Python actually counts. No, actually, if I'm not wrong, all the computers count from 0. So the first element in the list is the index is 0, and then 1, 2, 3, 4, 5, 6, 7, 8. So you see a list of a number like the first list ls over here. Yeah, so 1 is in its 0th place, and 2 is in the first place, and the 3 is in the second place. Yeah, and yada yada yada. Okay, so if I want to return the first element of the list, of the list ls, I'll type something like this. Okay, so it's 1, right? Then let's say I want to have a range of numbers. So let's say I want to have from first index to okay, last. Okay, last, you just type nothing, right? Okay, first to last is, oh, okay, what went wrong here? Okay. Nice. Okay, so it looks like I didn't run this properly. So yeah, then this is the first to last, and if I want to print maybe like I don't know, second to fourth. Uh, so it's gonna consist of just two numbers because Python counts. Okay, so the first element is inclusive and the last element is exclusive. So meaning that from if I want to, so meaning if I want to slice the list from 2 to 4, right, yeah, so it'll return me the second, okay, it'll return me the second place, okay, and the third place. Yeah, no, there's no fourth. Okay, do bear in mind that the second place I mean starting from 0, so it's actually third. I might sound crazy, but yeah. So just bear with it, okay? So you can actually slice it in terms of like step sizes as well. So let's say if I want to have ls, that is okay. So if I want to include everything, then or you just write leave it blank and blank. So that means that I'm including the zeros position here and the last position here, right? So 0, you don't actually need to do it. And the step size, maybe I want to have it like 2. So then you see it's 1357, meaning that all the even numbers have been skipped because it's step size 2, right? And if I want to print this, it'll return me a sequence that is in reverse order because it is -1. So meaning that I'm taking backwards. I'm going backwards by step size 1. So yeah, so that's how you actually slice the list. And okay, so there's actually a helpful resource that you can actually go to. It's a Python tutor. So let's say for example, hold on, let me exit this full screen, and let's say I wanna, okay, let's say I don't understand this ls line. Okay, oh my god, what just happened? Ls line, and okay, I don't understand how this works. So I just put it in, visualize execution, then okay, so you can just press on next and see what happens with like um, when the program's running. So yeah, okay, maybe this is a bit shorter to visualize, but yeah, so the list index is 0, 1, 2, 3, 4, 5, 6, 7, but the element, like the numbers are 1, 2, 3, 4, 5, 6, 7, 8. Okay, so yeah, okay, so you can actually use Python tutor to teach yourself Python. Like if you're not understanding anything, it's a great tool to have. And also, okay, moving on, moving on from the list, you can actually append. Okay, so like append meaning that, okay, so these methods are just things that you can do to edit your list. So let's say for example ls okay, sum list equals to can I do this, list range 9. Nice. Then if I were to print some list, it'll be 0 to 8, right? Amazing. So if I can actually like, okay, append the list. What do you mean by append the list? So some list dot append okay, 10. Okay, okay, no, 9. Okay, then I return some list. Okay, so append just means that this element has been added on at the back. Okay, so that's how it works. So remove some list dot remove 0. Okay, some list. Oh, okay, never mind. Okay, so okay, I can't run this twice because this has been committed to the memory, and yeah, so if I run it twice, there'll be some complications because list is actually a mutable data type. So yeah, what do you mean by mutable? Means that you can actually have the okay, okay, how do I explain mutable? Okay, mutable data types just means that you can do changes to the original like data that you have. So yeah, that's about it. Okay, next up we have is pop. So pop actually takes in dot pop, and you have to add in the index of the thing. Okay, index of the list, meaning that okay, if I want to pop out the number one, the value one from the list, I have to put in its index value, which is 0. So if I were to pop so yeah, so you see that one, the value 1, which is in the zeros position, is gone. So yeah, then a list extends some. Okay, another list, 10, 11, 12. Okay, so some list dot extend another list, return some list. Okay, so extend just means that you take in like another list, and it just appends that another list at the back of the list that you already have. So if I want to extend this sum list, so uh, I want to extend this sum list with the elements of another list, I just use the method extend, then it just adds on to the back. Right, so index. Okay, some list dot index. Index taking one argument, but zeros given, right? So there's a good thing about Colab actually. So Colab, you can actually see where you're getting wrong, and yeah, so as you can see here, some list dot index, the method index actually needs a value. So a value can be 12. Then okay, so this, what this does is it returns. Okay, let's say for example I want to know the index value of the number 12, right? So I just put in the index, then yeah, so then put in the method index, and yeah, that's how I get the index value of the value 12. Yes. Some list dot insert, you know what, let's say 24 3. Okay, is it 324 or 24 3? Okay, okay, we'll see then. Okay, nice. No, not nice. Okay, okay, so this is already okay. Insert 323. Ah, nice. Okay, so the insert function, okay, so the insert method takes in the positional value and the value that you want to add on. So for example, I want to add on I want to add on the value 23 to the third index. So meaning that 1, okay, 0, 1, 2, the third index, it has been inserted, the 23 has been inserted, then there's 4, 5, 6, 7, 8. Okay, yeah, so that's how it is. And then you can actually sort the list. So you see that this list is super duper messy because it's all over the place. So you can do something like list, some list dot sort, some list. You do that, and the list is sorted. It's in ascending order, and if you want to do it in descending order, I think you can do it as ascending equals to false. Is it ascending equals false? Is that how it works? Okay, no, it's not. Okay, ascending is an invalid argument. Okay, all right, fair enough. Or alternatively, you can just have it such a way that like this. So yeah, it's in descending order now. Cool, right? Okay, so right now we're on this coding bat website, and there are actually a lot of kind of exercises that you can do. So let's say for example I want to go to list one, and yeah, so okay, you see a prompt over here: given an array of integers, return true if 6 appears at the first or the last element of the array. This would actually need a bit more boolean in this case, and we haven't learned it yet. So I can skip this for a moment, but this is a fantastic website for you to practice your coding and stuff like that. So just a little exercises that you can do on this coding bed website. Okay, next up we have a data type called dictionary. So a dictionary is a kind of a data type that uses key and value pairings to have a correlation values. So it's kind of a 1-1 function. So what do I mean by this? So let's say for example I want to have okay, so let's say for example it's a shopping list, right? Then I have apple. I want to buy 5. Okay, and then comma banana. I want to buy 3. So on and so forth, right? So this is an example of a dictionary. So the keys are the indexes of the dictionary. So what do I mean by this? The index just means the apple and banana. So yeah, so if I want to get the keys of this dictionary, oh my god. Okay, if I want to get the keys of this dictionary, so I just type in dd dot keys, and yep, the dictionary keys is apple and banana. And dd dot no, it's not items, so it's values. Okay, so the values are 5 and 3. Yeah, and then items. So items, they just give you items, they give you a pair. So like both keys and the values. So items, apple 5, banana 3, right? Okay, so you can actually update the dictionary. What do I mean by this? So let's say for example new dd, and I say something like watermelon 7, because watermelons are good. Okay, then if I want to put this new dictionary into the previous dictionary that I have, so I just dd dot update new dd, and then if I were to have the dd dot items, shabam, you have apple, banana, and watermelon, right? Cool. So this is essentially what a dictionary is. So if you want to, yeah, we can actually go further with dictionaries. So like okay, maybe not import yet. Okay, so maybe for example, oh wait, no, I can actually import pandas as pd, and so this is essentially like kind of like your basic to data science, I suppose. So data frame, you have list. Wait. Okay. So let's say for example the index is fruits, and okay, okay, one thing that I forgot to tell you is a dictionary is defined by this curly brackets. So whatever it is curly brackets is like a dictionary, right? So fruits, list, dd dot keys. Okay, so this is so you might not know what's going on, but it's fine. Quantity, list, dd dot values. I don't need a capital V. Values. Okay, df. Pandas have no. Oh, the F is capitalized, I think. Yes. So dictionaries are essentially like the first kind of building blocks for you to like go a step further with like data science and stuff like that. So yeah. So what this code Okay, so what this code actually does So what this code actually does is that I import a library called pandas, and pandas is just like a data science or like a data analytics tool that you can use to like see data frames and stuff like that. So I'm making a data frame called df, and I put the index as fruits, and I put the keys, which are the fruits, apple, banana, and watermelon, as fruits, and the quantity, I put the values of the dictionary. So yeah, if you want to step if you want to step one step further with the dictionaries, you can actually use dictionaries to kind of make data frames and stuff like that. So it's pretty awesome. So moving on to conditions, right? So definition of a condition. Okay, so okay, I'll just do the coding first, then I'll explain to you what it's actually doing. So return he xd elif x equals to 3, return haha elif x is less than 0, return lol else return okay. Okay, so I've just written this code, and okay, now I'll explain to you what it's doing, right? So I just need a few more lines of code. Sample condition, run this function. Okay, so the x value, let's say it's 5, 3, -2, 7, and 900. Okay, 9,000. Yeah, because it's funnier. Okay, so run. Okay, it's running. Okay, nice. So sample condition. Okay, so what this means that, okay, so this is basically a Boolean condition that we have discovered in the list exercise earlier on. So what this code is actually saying is, okay, given the input variable x, if x is 5, if x is equals to 5, then print he xd. Okay, fair. Then else if okay, else if is like or elif is like something like, if x is not 5, yeah, then if x is 3, then put haha. So the boolean okay, so the function checks, okay, 3 is definitely not 5, so it didn't print he xd. So so it checks the second condition. So if x is 3, is x 3? Yes, x is 3, so it puts haha, right? Amazing, right? Then for the same thing with -2, so x is okay, so x is not 5, okay, so it's not going to print he xd. So x is not 3 either, so it's not going to print haha. So if so is x less than 0? Yes, x is less than 0 because it's -2, then it prints lol. Then if x is none of these numbers that we have checked above, so it's not 5, not 3, nor is it less than 0, then like else, then when that happens to like be the case of else. So if everything else fails, then just return k. Yes, that's what it means. So yeah, so these are the conditions that we have. So it's just if, elif, and else. Yeah, so now I wonder if this is a good example or not, but if you're still not sure, leave it down in the comments. Yeah, I'll try to edit here and there for the notebook, and I'll give you guys an update about it, right? So next up we have for loops, right? For loops, what do we have in for loops? So for loops are just okay, I'll just give you an example. For I in range 3, print I. Okay, so what this code is doing is that for I in range 3, meaning that from range 0 to 3, yeah, print the I, which is 0 to 3, right? Then maybe I want to have it like for I in range 2 to 9. Okay, shucks. Is it? I think it's uh, comma print I. Yep, it's comma. So yeah. So so just like I said before, so if you give a range of values, so the first number is inclusive and the last number is exclusive. So that's how you know that how the computer is counting. So if you say a range is 3, then it'll start counting from 0, 1, 2, 3. Then if you say the range is from 2 to 9, so it'll count from 2 to 8, right? So yep. Okay, maybe for for loops we can actually use a Python tutor for it. Okay, so maybe this example, control C and control 2, no, control 3, no, control 1. Okay, where's Python tutor? Python tutor. All right, nice. So just visualize execution. Okay, so you have this Python tutor website, and yeah, you just plug in a line, and yeah, so the green is the line that just been executed, and the red is the next line to execute. So the computer read this for I in range 3, then it knows that you have to repeat the code 3 times. So you have to run the code 3 times. So the I value of this, so the I value is now 0 because yeah, you start from 0. And yeah, the next line to continue is print I, so it's gonna print 0, right? Then it is a for loop, so it's going to keep repeating until it finished 3 cycles. So meaning that okay, it goes back to the top, then it goes back to bottom, goes back to top, goes back to the bottom. So it's like it keeps repeating until you finish the loop. Okay, so that's essentially what a for loop is. Then we have enumerate. So enumerate is more of like okay, list Oka, I don't know, probably Messi, Ronaldo. Okay, nice. For I, J, and enumerate ls, yes, print ij. Okay, so for this code, it's actually taking in this list and kind of giving its index. So it's kind of like for ij, so I is going to be your counter and j is going to be the, how do you say, the element in the list. So for ij in enumerate ls, print ij, so meaning that I is going to be your index, which is 0, 1, 2, 3, 4, 5, like so on and so forth. Okay, in this case 0, 1, 2, and then j is going to be the element in the list, right? So we can actually, if you have 2 lists, so let's say teams, just say PSG, Lakers, and what's okay, guess what, menu. Okay, nice. And then you have players. We have Messi, LeBron. Okay, the B should be capital. Sorry. And Pogba. Okay, so if you have if you have a list of, so you have 2 lists having the same length, you can actually have it zipped in a way like for ij in zip teams players print ij. Boom. Okay, PSG, Messi, Lakers, LeBron, and Menu, Pogba. Okay, so okay, so this is gonna be a bit of a like spoiler for what we're gonna have next up, but we want to actually format this string to make it look nicer. So 8s dot format I j wait. Aha, okay, looks much nicer, right? Okay, so okay, then we have while loops. So while loops are just kind of for loops, but it goes on like for like infinite number of times until you give like a stopping position. Okay, so what do I mean by this? Let's say for example I say number is 5. Okay, no, number is 0. While number uh, is less than 5, number plus 1, assign the number, print number, print final number, number. Oh shucks, I just say number. Okay, so while loop, it's basically that a loop that goes on forever. So we want to have like kind of like a stopping point. So okay, let's say for example, okay, I don't want to crash my computer, but sure. Okay, so while true, print dot. So basically when I run this code, it's never going to stop unless I stop it manually. So what I mean by this, so while true print dot, meaning that it's going to print dot forever and ever until it's going to have no stop. Because yeah, you see it's, oh my god, there's so long dots, and it's so it keeps on buzzing, so like, so it's never going to stop. So you actually have to stop it manually. And yeah, so that's how you know that while loop continues on forever. But you can actually stop it with this kind of architecture. So you have a number, a counter number that's 0. Then I have a condition that while the number is less than 5, okay, while the number is less than 5, I want to add 1 to the number and print the number. Okay, so what's happening is that, okay, now the number is 0. So number is still less than 5, right? Yeah. So I'm going to add 1 to it. So 0 plus 1 is 1. Then I'm going to print the number 1. Okay. Then your number now is assigned the value 1. Okay. So it's in a computer memory that the number is now 1. So 1 is still less than 5. Then you're going to add another one, like, so it's going to be 2. Then the print number 2. So it's going to be 2. Then so the computer now remembers the number is 2. Then so I'm going to explain this one more time again. So the number is 2. 2 is less than 5. So we're going to add 1 to the number and assign the number as, okay, now the number is 3. Then you're going to print the number, there's 3. And yeah, so it just keeps on going until the number hits 5. So the final number is 5, right? So, okay, terminate a program. So let's say, for example, x equals to input. Press 0 to terminate the program. Okay, so if we just input x and equals 0, it's going to be in a string format. So we want to change this string format to an integer. So x equals to integer x. Then we say while x is not 0. Oh yeah, this is another boolean conditions that you can learn. So it's exclamation and equals, it means it's not. So while x is not 0, input, okay, we just copy this here, and after that print the program has been terminated. goodbye. Okay, so okay, we have this program that's running, so it keeps buzzing because it's a while loop. So yeah, so right now we don't have any values assigned to x, so let's just say input 5. Then since 5 is clearly not 0, then yeah, so it's gonna prompt me to put again, let's say 42, 89. Okay, so it's gonna keep on doing forever and ever. And okay, so because of this architecture, I can't actually put how do you say alphabet, because alphabet cannot be converted to an integer value. So 89, 90, 76. Okay, then I put a 0, then the program has been terminated. Goodbye. Yeah. So it will keep on going until my input is 0. So yeah, so that's how while loops work. And yeah, so moving on to strings. Okay, how much time do I have left on my camera? Hold on. So a string is just something like message equals, this is a string. So it's just something that you display on your computer. So it's, yeah. Then a string, you can have it such that message dot upper, so it will give you like capitalized, everything is capitalized. So this is a string. Message dot lower, it will give you some everything in lowercase. And message dot replace, so replace just means that what I want to replace it with. So the old one is gonna be I want to replace I with a star. Where's a star? Nice. So it comes out, this is a string. So strip, okay, strip just means that, okay, I have white space over here. Yeah, so this so the string consists of this all white space because the parentheses ends all the way over here. So when I strip the string, it's going to be message dot strip. Oh no, and message dot strip. Yep, so now it's stripped. And then you will soon realize that message dot in split. Okay. Oh, okay. This is interesting. Okay. Yes. So so when you see that the message when you see it in message dot split, and if I want to split it by just the, yeah, if I want to specify that it is splitting by spaces, you actually see that there are a lot of spaces left here. It's because string is a immutable object, so meaning that it's not like a list. Like, so for example, like if I append some list, then it automatically update to the original copy. But if I were to do it, any changes to the message, I wouldn't have made any changes to the original string that I have. So yeah, so this is alpha. Message dot is alpha. So when I have this, so when I input this, it's not gonna be so even though if it's all alphabets, it doesn't register as is alpha because they're actually white spaces, basically your space bars. So I'll say another message equals to this is a string. Then I want to check if okay, so I need to use print. If not, it's not gonna register. Print another message is alpha. So yeah, so and when there are no spaces in between, it's actually written as true. So Is digit is the same thing, but you know what, I'm getting lazy, so I'm just going to put MSG 34 and just gonna copy paste is digit print msg dot is digit. So yeah, so is digit just means that if it's a digit, then it will return true. In this case, message like it's not a digit, so it returns false, and 34 is a digit, so it's a true. So alnum is actually the same thing. It's just alphanumeric. So meaning that okay, I just put here, here, and print. You know what? I don't want to assign Oka 1 2 3 is alnum. Yeah. So if you're getting lazier like me, you can actually not assign, not commit like any variables, not assign any like values to the variables. Yeah. So alnum. Nice. So if you have so from this message, so from this alnum, you can actually see that if there are spaces in between, the alnum is false. But if there's just alphabets, or it's like both alphabets and numbers, the alnum will be true, right? So next up is formatting strings. So formatting strings just means that okay, so this prompt says print hello world 3 times. So I'm gonna say for I in range 3, because it says 3 times, print hello world. Okay, so it's gonna repeat 3 cycles and print hello world 3 times. Right now, it tells me to print hello world 3 times in a single line. Shucks, how do I do it? Okay, so for I in range 3. Okay, so you can actually do it like this, or also you can print hello world times 3. Yeah, so you can either do this, or you can do something fancier, like print hello world n equals, yep, so it's the same result, but it's just a different way of coding. Yep. And let's say for example, just now the introduction, the name and the age. So name is Oka, age is, you know what, 21, and I want to say, okay, so traditionally, before any formatting, you will just print like print my name is plus name, and print I am plus age plus years old. So as you can see, this is incredibly long, and it's super inefficient. So you can actually try and format as such. So just print my name is okay, just curly brackets, and I want to put another line. I am age, so years old dot format name and age. So what do we mean by this? So it just means that my name is some placeholder here, and this will be a new line, and I am some placeholder here, years old. Then the name, the first so the first variable that we have, the name, is going to be input at the first placeholder here in this curly brackets, and the second variable is going to be on the same as on the second placeholder. So if I run this code, it's the same thing, but it's super duper efficient. Yes, and yeah, okay, you actually have try yourself kind of exercises that you can do over here. Okay, so my camera placement might be a bit different because my battery actually died. I've been recording this for like an hour or so, but you know, in the edits, it may not look like it. It's a lot shorter actually. So for the last segment, we're gonna go through something called object-oriented programming. So and basically these are just classes that you can actually define yourself, and yeah, so and you can do a lot of like things with it. You can be creative, but like I'll just give you a very brief introduction of it. So let's say I want to have a class called my rectangle. Yeah, you may or may not have realized that I actually there's actually like the prompts for me, like it's because I just deleted this so that I can actually show you everything in full, right? So in a class, then you can actually define functions over here. So define firstly you have to put in it. Okay, so in it, so in just two underscores and an init, and you want to have self. Then the rectangle should have the parameter of length and breadth. Then after that you have to define what these variables are. Self dot length equals to length, self dot breadth equals to breadth. Nice. Okay, then after that you want to continue on with defining other functions that you want to have. So maybe I want to calculate perimeter. Nice. Then I call self. Nice. Then after that so I return the parameter, which is self dot length. So if you're calling so if you're going to use any variables that you define in your classes, you have to actually use the word self, so that yeah, so you can call them properly. And maybe just another calculate area self, just another function to add on. Return. Okay, I'm just gonna copy because I'm lazy. Okay, so it's length times breadth. So after I define this sample code, let's say some rectangle equals to my rectangle. So meaning that this some rectangle is going to be classed under my rectangle, and I'm going to give some rectangle a parameter of 8 length and breadth 5. And yeah, so I'm just going to define it here, and with two quotes please. So let's say I want to calculate some rectangle dot I want to calculate the rectangle of some, okay, rectangle of, okay, I want to calculate the perimeter of some rectangle, right? Yeah, so I just call this function, and yeah, so 8 plus 5 is 13. 13 times 2 is 26. So yeah, you know what, fair enough. And okay, then after that some rectangle oh shit, some rectangle dot calculate area. Then I'll have 40, which is 8 times 5. Yes, amazing. So you can actually discover a lot more, no, you can actually explore a lot more variables and kind of classes that you have. So with like object-oriented programming, and yeah, okay, I'm actually getting tired. Okay, so Another class that I define is my student, so it's like a database of the students. So let's say for example self name class. Okay, class I spell it with double A. So because class is an inbuilt function, so you cannot have class as a variable name. So you see over here the class has a different color that indicates that it's actually a inbuilt function. So it's something like so if there's something like max or min or yeah class type, yeah, they're actually inbuilt functions in Python, so you can't use them as variables. So yeah, you have to spell it a bit differently. Then you have age, contact number, and yeah. So let's say I want to have have a printout of a full detail of the student, and I'll have the list uh, of the indexes, and then I'll have a list that of the values. Then after that I'll just print as such. Okay, then yeah, so let's say okay, let's say this is my details, right? Yeah, Oka is this is my name, the class 4A, age 21, contact number 91234560. Don't call me at this number, right? If you want to call me, DM me, right? Okay, so yeah, that's basically it for object-oriented programming, and you can actually try it yourself over here. Like you can define a Pokemon class like self name type HP attack and defense, so you know just print out the full details. You can use this as a reference, uh, and yeah, uh, that's about it really. And if you want to go a step further, I actually have something like printing the receipt. This is actually it might be a bit difficult, but I'm sure you can do it. Yeah, you're pretty smart. I believe in you. So that's it for all the tutorial there is. If you want to know like a lot deeper into if you want to know a lot deeper of the Python syntax or strings or booleans, the nitty-gritty details, right? You can actually visit W3 Schools. It's actually a very very good resource that you can actually have. So like let's say operators, or like or some things that I didn't show, like tuples. Tuples are like list, but I don't really see like them as that useful. So yeah, I didn't really go through it over here. So dictionaries, then if else, yeah. So you can know more about this in W3. And remember to check out Python tutor as well if you're getting lost and you need help with Python. And what else is there? Oh, coding bat. Yes, coding bat for more exercises that you can train yourself to be better at like um, programming. Yep. So just as a final note, I'll leave this Google Colab notebook link in the description down below so that you can actually check it out and try these exercises by yourself. And yeah, so that's it for the video. I hope you enjoyed it. I hope you learned something new. And I'll see you in the next video, I guess. Adios.